Hello, we are discussing about GATE 2011 ECE paper. For the given transfer function g of j omega is 5 plus j omega n, what is the corresponding Nyquist plot for positive frequencies? Nyquist plot for positive frequencies. Positive frequency is the omega value is changing from 0 to infinite. As the value of omega changing from 0 to infinite, what will be the magnitude and what will the phase angle? That gives the plot which is called as Nyquist plot. Nyquist plot for positive frequencies is same as polar plot. Okay, and if you take negative frequencies also, that is omega is equal to minus infinity to 0, then the total plot is going to be treated as Nyquist plot. Okay, so half of the Nyquist plot, that is Nyquist plot for positive frequencies, is same as polar plot. So simply you are going to write a polar plot for the given transfer function. But before going that one, directly we can say the answer from this expression. G of j omega is given as 5 plus j omega, that has the form of sigma plus j omega. So sigma is real part and omega is imaginary part. From this one, sigma is equal to 5, which is constant. So real part doesn't change and imaginary part is getting increased. So that waveform is going to be this one. This is a real part. Okay, from 0 to 5, this is sigma value, and this value is going to be constant at any frequency. Whatever the frequency you will take, the value of sigma value is constant. So the right answer for this question is A itself. Okay, then how can we say that one? What can be the polar plot of this one? Okay, polar plot, we know that one, it will be consisting of magnitude and phase angle for the given frequency omega, and polar plot starts from omega is equal to 0 to and omega and end set omega is equal to infinite, and at each and every point we need to specify the magnitude and phase angle for all values of omega. That is what we can get from the polar plots. Okay, so how can we say that one in this one? What can be the magnitude, what can be the phase angle corresponding to this one with respect to polar plot? For your information, I am giving this one. Okay, otherwise you can stop. Directly the answer is A, which you can get directly from the expression. Now, polar plot requires magnitude and phase angle. So, polar plot is going to be taking the form of r theta, that is r is the magnitude of the given transfer function, theta is the phase angle. Okay, so now I am going in this way. This is a plot omega, and next r value is nothing but magnitude of j omega. Okay, and next theta is nothing but angle of j omega. And at any omega, for any given omega, we can say magnitude of this one, that is square root of a plus jb is square root of a square plus b square. A square is nothing but 25, 5 square plus omega square. This is magnitude at any frequency omega, and phase angle is tan inverse imaginary part by real part. Imaginary part is omega, real part is phi. So now I can start at omega is equal to few points I can take. Let us assume omega is equal to 0. So substitute 0 value over here. 25 plus 0 is 25. Square root of 25 is 5. Tan inverse 0 by something is 0. Tan inverse 0 is 0 degrees. Next, let omega is equal to 5 is another point. Then find the magnitude and phase angle. Omega is 5. 5 square is 25 plus 25. That is 50. Square root of 50. Square root of 50, whose value is 7.07. Next, tan inverse 5 by 5, that is tan inverse of 1, which is nothing but 45 degrees. And let us assume omega is equal to infinite, that is final point. So infinite will be, magnitude will be infinite, and this is tan inverse of infinite, so it will be equal to 90 degrees. So this is a table corresponding to polar plot, and if you observe, magnitude at omega is equal to 0 and phase angle at omega is equal to 0, we will indicate in this way. So first omega is equal to 0. By that time magnitude is phi. So this is phi and phase angle is 0 degrees. Okay. So this is, we can say it as omega is equal to 0. Next, at omega is equal to phi, phase angle is nothing but phase angle when compared to positive real axis. Okay. Next, when omega is equal to phi, square root of 50 is the magnitude, that is 7.07. So this you are going to get it. This is 7.07 and the phase angle with respect to positive real axis, that is 45 degrees. It is second. And if the omega is increases, say omega is equal to 10, 15, 20. So by that time you are going to get the lines like this. As omega increases, phase angle increases as well as magnitude increases. So at one point it is going to be touching this phi at any cost. Real part is same. Okay. So under infinite it looks like it is asymptotic to j omega axis by that time. Okay. It is asymptotic to j omega axis. By that time it will be having a phase angle of 90 degrees. So this is a polar plot, that is you are going with the same graph, but polar plot you must understand in this way. Okay. So looking in a polar plot aspect is different from the S-plane aspect. So this is how you must think in terms of polar plot. Okay. Thank you. So the right answer for this question is anyhow A only.